We're going to talk about some of the basic charts that you'll see within the discipline of quality control. You should already be familiar with the concept of voice of the process. And what we mean by the voice of the process, just to recap, is that we collect data from the process. Once we have that data, we will statistically manipulate the data, place it on a chart, and then use the chart to provide us an analysis of what's going on or what we think may be happening. And the four primary charts we're going to look at are the bar chart, the line chart, the pie, and the XY. The bar chart is laid out on a X, which is your horizontal, and a Y, which is your vertical axis. The X-axis always indicates a category. So in this case, what I've got is I've got production data from the RV chiller company, and I've got the first quarter here, January, February, March, and April. And obviously on your chart, it would be more detailed as to what the month is. I've just abbreviated it here. Along the Y-axis, then, what we have is what we call the frequency axis. Means in January, what was the frequency of production, or how many units we produced? And obviously you can see we produced 700 units in January. And then you simply have a bar that represents the data that shows the number, the production level for each month. The nice thing, or the advantage about the bar chart, is that if you want to be able to talk about comparisons between one category's production versus another, it gives you a nice visual look at how does January compare with April. Obviously we know that April is quite a bit lower, but this allows us to easily see those comparisons. On many of these charts we will also put a grid line across just to make it easier for the person who's looking at it to trace that top of that bar back to a numeric value on the y-axis. Now I've used the exact same data for this chart. It's a line chart. You'll notice it's precisely the same. Your x-axis is your category axis, your y-axis being your frequency axis, and then instead of the bars at the same level, I've simply plotted what's called a tick point, and that tick point represents the level of production for each month, and then connected those with a line. The line chart is beneficial when you want to look at what we call the behavior of the data. In essence, here it's easy to see that we have a declining production. Sure, you can see that back over here, but the line chart in the long run is your chart when you want to talk about the behavior. How does the data moving? You know, many times you'll see charts where you'll see it slope down and come back up. You know, in an industry like RV chiller, though you don't have all the data, there are production lows and there are production highs, and they relate to a seasonability trend. They're obviously going to be making more when they're ramping up for the summer than they are during the winter months. And in looking at that, you would see that behavior, that production behavior. The pie chart. The pie chart again takes the same data, but what it does here is it takes that data and it represents as a percentage of the total production for the entire year. So if we go back here, we see that 700 units, we don't know what the total was, but 700 units represented 20% of the total year's production of the chiller. February was 19%, March 17%, and April 14%. What this does is this allows us to look at each category from a perspective of percentage of a whole without the person getting tied up with what the numbers are. Many times, if you want to discuss a situation, it's advantageous to leave the numbers off. People get too tied up with the numbers. Oh my goodness, 700 versus 400 down here. What we want to do is look at it from a standpoint of percentage. Well, how does this sales break out, or how does production break out as a percentage? We want to talk about those relationships rather than the actual numbers. Probably the most sophisticated of the charts is the XY. The XY chart changes things a little bit, and what it does is it takes a look at two related items of data. And the two related items of data we're looking at here are the units produced. All right, we had that over here. The units produced, so what if I produce 25 units, 50 units, 75 units, 100 units? And now what I'm looking at on my y-axis is my electrical cost. So in essence, I basically know exactly how much electricity it takes me production-wise to produce a unit. And then as I've produced the units, I've plotted the electrical usage in respect to that. So I have two related items of data, production and the electrical cost of that production. The x-axis on an X and XY chart is referred to as the independent axis. This is the key, or the start point. In essence, what I'm saying is, this is the dependent axis. What I'm saying is that the amount of electricity I use depends upon how many units I produce. All right? And anytime you're looking at setting up an XY chart, you have to take a look at the data, your two pieces of data, and say, okay, which one is the result of the other? Which one, in other words, which one depends upon which one? And that dependent data then is your y-axis value, and the other would be the independent axis value. So now I've simply plotted it, and you see I've got a line that's moving up the road here. Typically, on these kind of charts, it's good, they'll show you if there's what they call a linear relationship. For example, if I have a straight line, or pretty much a semblance of a straight line, then that means that my dependent data is happening in what we call a linear fashion. In other words, it's consistent. On the other hand, if I were to see this thing swing sharply up, it would indicate to me at that point something has happened in respect to production that has caused a sharp increase, and we no longer have this linear relationship. It's good to know that. Also, with this chart, what you'll find is that this data will never approach the bottom. It'll never hit zero. And the reason for that is, even though I'm not producing anything, that line may still be running at idle, and when it's running at idle, it's utilizing electricity. And again, another advantage of this chart is it'll show me what my electrical cost will be when my line is idle. So I know that that's a constant that's there. So like I said, we're going to look at many other charts throughout the course of the semester, but these are the primary ones and the primary concepts. The important thing to keep in mind is that once you've collected the data, that has to be manipulated in some fashion and then shown in respect to a chart. When you're presenting the data, you think about your audience. What do you want to tell your audience? Do I want to talk to my audience about the relationship of categories? Do I want to talk to them about a behavior? Do I want to talk to them about processes as representative as a percent of the whole? Or do I want to do some form of related data comparison? You need a chart that focuses on what you want to present to your audience.